Problem 130, we're taking a look at an object that's shot into the air. And we have an equation right here that works with this. So h is the height in feet after t seconds. So t is your time in seconds. Most times when you are dealing with gravity, anything that's affected by gravity, you will have a quadratic because gravity within itself is actually a quadratic. So we are looking at objects now. At what time will they be on the ground? On the ground means your height is going to be 0. So I have 0 equals 80t minus 16t squared. Right away I can notice that I can factor a t out of this. There's actually other numbers I can take out as well. But just for the sake of this problem right now, I'm just going to factor out the t. So t times 80 minus, that's not an 80 minus 16t. And now doing zero product property, I have t equals 0 from this first factor. And 80 minus 16t equals 0. So 80 equals positive 16t. And t will then equal 80 over 16, and I will simplify that fraction. So t will equal 5. So that means that it's on the ground at 0 seconds and 5 seconds. So what I'm going to do now is I'm actually going to make a quick sketch of maybe what this would look like. Notice that this is a negative 16t squared, even though it's written in a different order. Negative 16 is your leading coefficient, so this parabola opens down. So if I would graph this, at 0 and at 5 would be the x-intercepts, and it would look something like this. So for what domain is the function reasonable? Well, your x value is from 0 to 5, because the parabola is not going to continue this way and going negative, a negative height. So for only 0 seconds to 5 seconds, our x values really work. Problem C says how long did it take the object to hit the ground? Again, 5 seconds, because it left here and went up in the air for a total of 5 seconds and then hit the ground. All right, for problem D now, we want to know at what times is the height greater than 64 feet. So we want to figure out, notice I did not put a y scale over here, but somewhere over here is going to be a height of 64. We want to know at what point is it higher than 64. So to do that, I'm going to take my equation and set equal to 64 and solve. So it'll be a quadratic, and I will solve that. So 64 equals 80t minus 16t squared. I'm just going to move that and that over to that side to keep my leading coefficient positive. So I will have positive 16t squared minus 80t plus 64 equals 0. Now, just to make this a little bit of an easier problem, I know that every single one of these right here I can divide. And I can actually divide them all by 16. So when I do that, I will get t squared minus 5t plus 4 equals 0. So 16 is just the stretch factor for this one, but the stretch factor is not going to necessarily make a difference when we go through and set it equal to 0 and solve. So now I have this, and this will factor into t minus 4, and t minus 1 equals 0. So t will equal positive 4 and positive 1. So if we go back to what our sketch looked like earlier, so the x-intercepts were at 1 and at 5, and it went up like this, which means at 1 second and 4 seconds, that would be your 64. So it is higher than 64 feet between 1 second and 4 seconds. Also, if we want a height greater than 64 feet, it will equal 64 at these. So if we want to write this as an inequality, it would be 1 is less than t, which is less than 4.